Hello College Algebra and welcome to Chapter 7. This is on conics. 7.1 is ellipses and then we'll do hyperbolas and parabolas. And it's a lot of graphing, so make sure you got your pencil out, you're ready to go, and your calculator, and let's have some fun. Okay, whoops, this is a little high up. Alright, when we're looking here, we are doing ellipses. So an ellipse is like a circle, or it can be, but it's in an oval shape is what we want. So when you do an ellipse, let's go down here. It's a set of all points P in a plane, the sum of whose distance from two fixed points. All right, these fixed points, F1 and F2, are called foci. So there's a point here in an ellipse and a point here. Now, if I gave you a string and we connected the string so it was taut here and we put a pencil around it, this string would be taut all the way around and create this ellipse, is what happens. All right, so we're going to find the vertices, which are the points on the ends, like here and here is a vertice, and actually up here and up here is a vertice. There's a center, and then there's the foci. And those are the things that we need to find when we're working on an ellipse. So when we go this direction, when we do the vertex, if the major axis is always the longest one. So if the longest one is on the y, then your ellipse is oblong this direction. And if your major axis is on the x, then it's oblong this direction. You still have your minor axes here. That's why you have 4 of those, with the center, and then the foci is always on the major axis. All right, so we want to graph an ellipse. We're going to start with ones that are centered at the origin. So when they're centered at the origin, we have an x squared plus a y squared is what we're looking at. All right, you take the square root of a, or the one underneath the x, and the square root of what's underneath the y, and that's the distance from the origin that you go. So I would go a, left, and right, and there would be one vertices, those are one set of vertices. Then we would go b, top and bottom, and that'd be your other vertices. Now to find c, it's inside, so it has to be smaller, so we are subtracting. We take a squared, the larger, minus the smaller, and then we take that square root, and that is what gives us c, and that's where our foci are. So it's always the larger minus the smaller on an ellipse. All right, so here we go. We're going to write it in standard form, means it's got to be set equal to 1. We're going to find a. We're going to take the square root of the largest. We're going to graph it. We're going to take the square root of the smallest. We're going to graph it. Now these are our major and our minor axes. We're going to take the larger minus the smaller and take the square root, and that's going to be c, and then we're going to graph our foci. So step 1, we have to set this equal to 1. So we divide everybody by 144. And of course we're going to make these pretty to start with. So we divide it by 144, so the 144 cancels to 1. 144 divided by 16 is 9, and over here is 16. So now when you look here, the 9 is with the x. So since the 9 is with the x, the square root of 9 is 3, and this is on the x-axis. So we go on the x-axis, we're going to go left, and right 3. So we got -3, 0, and 3, 0. The larger is 16. Square root of 16 is 4. It's under the y, so it's on the y-axis. So this is my y variables, or my y. So we go 4 on the top and -4 on the bottom. Now we got to find c. c is always the larger minus the smaller, regardless of where it is. So we have the 16 minus the 9. Then we take the square root of 7, and the square root of 7 is going to be on the y-axis because this is my major, because your largest is always the major axis. So this is always on the major axis, and since it is y this time, it is going to be a y value. And the square root of 7 is like 2.6 and -2.6. And then you just draw in your ellipse, connecting all your vertices. Quite fun, right? Okay, pause and try yours. So your step 1 is you should have divided everybody by 100. So now you've got Now you've got x squared over 25 plus y squared over 4 equals 1. Now, this time, your major axis is going to be x because it has the larger number. So you're going to take the square root of 25, which equals 5. This is the x value, so we'll have 5, 0, and negative 5, 0. So we graph those, 5, 0, and negative 5, 0. Now we do the minor axis, which is this, the smaller of the two. So this is going to be y this time. Square root of 4 is 2. So we have the y value, which is going to be 0, 2, and 0, negative 2. And we graph those. All right, so right now we have my vertices of my ellipse. Next, you have to find the foci. The foci is the larger, 25, minus the 4, which is 21. So the square root of 21, and the square root of 21 is going to be on the x-axis, and because the x is the larger of the two. So this is roughly 4.6. So we're going to go 4.6, comma 0, and negative 4.6, comma 0. X-axis, because it was r. So this is c, and it's going to be on the x because that is our major axis. So 4.6, 4.6. Did I graph that? Oh, wow, I can't graph on 5. Shame on me. Put that back down. I did it again. Okay, and draw in your ellipse. All right, I hope you did a good job. Okay, now we're going to write the equation. So we're going to go backwards. Still in standard form, still centered at the origin. So we haven't done any transformations yet. So my foci is negative 2, 0, and 2, 0. So since negative 2 is the x value, that means my major axis is x. All right, gives us c equals 2. Okay, now my vertices are negative 3, 0, and 3, 0. And they're also the x, so this here is my major points. Since they are on the x-axis, so I know a is equal to 3. So now we know c and a. We know that c squared is equal to the major axis, this time a squared minus b squared. Well, this time c squared is going to be 4. This is equal to b squared, or a squared, which is going to be 9, minus b squared. We're going to solve this, so we're going to subtract 9, giving us negative 5 equals negative b squared, divided by the negative 1, square root, and we get the square root of 5 is b squared, or is b. All right, but when we write our equation, we know it's x squared over a squared plus y squared over b squared. So x squared is over the square, so that's going to be over 9 since it was 3 squared, correct? And then the square root of 5 squared is just 5. So we've got 9 and 5, and we are done. Okay, pause and try yours. All right, now when you look at yours, your foci are on the y, which means your major axis is y, okay? And c equals 2, so c squared equals 4. Here, they gave you the major vertices because it's the y value. So this means your a is going to equal 4, so your a squared is going to equal 16. So now when you have to calculate your b, you know that that is c squared, so 4 equals a squared minus your b squared. Subtract this out, get rid of your negatives, and square root. So b squared is now the square root of 12. So now we got to write our equation. We got x squared plus y squared. We know y is our major, and we know our major axis is 16. We know x is our minor, and then b squared would be 12. And that's your equation. I hope you did a great job. Okay, now when we move, it's just like every other move we've done with your transformations. You'll have an h and a k. So whatever's with the x moves on the x-axis, whichever's on the y moves on the y-axis, and it's always opposite of what's inside of the parentheses. All right, and again, whichever one is the major, it's going to have the larger one on in the denominator. So let's go here. Let's start with this. is. We could graph the parent graph and then move, which we may do just so you understand. So right now we know our major is going to be the x because it's 9 and it's larger than 4. So we're going to go 3 because the square root of 9 is 3, left and right. And then the square root of 4 is 2 and 2. All right. Our foci we know is going to be 9 minus 4, which equals 5. And then the square root of 5 equals your c. So 2 point. So there's your foci. And then we graph in our ellipse. Now your transformation says I'm going to move it right here, left 1. So I'm going to move my center. You're looking at your x plus 1. So we got x plus 1 set equal to 0. So x is going to equal negative 1. So my center is going to go at negative 1. And the same with the y. So y equals 2, negative 1, 2. So I have to move my center from here to negative 1, 2. So it's going to go up here. Now what you're going to do with all your vertices is you're actually just going to add that point to it. So we can either move each one negative 1, 2, or we can actually show that math. So let's do that math just so you know you understand. So we know our original vertices are, let's start with the x values, negative 3, 0, and 3, 0. So now when I add negative 1 to that, I'm going to be at negative 4, because negative 3 and negative 1 is negative 4, 2. And my other one is going to be at 3 and negative 1 is 2, 2. So if you look, if we took these endpoints and I moved left 1 up 2, I'm at 2, 2. If I take this endpoint, I move left 1 up 2, I'm at negative 4, 2. So it works both directions. Now let's do it with our minor. So our minor was 0, 2 and 0, negative 2. And we do the same thing. So it would be negative 1, 4 and negative 1, 0. So let's see if that works. We take this point, we go left 1 up 2, negative 1, 0. Take this point, left 1 up 2, negative 1, 4. Works fairly well. Now we know our foci is at the square root of 5. So our foci was, I forgot to draw him in. He's on the major. So square root of 5, 0, negative square root of 5, comma 0. All right, so now when we add negative 1, 2 to that, well, square root of 5 is roughly what? Let's see what that is. .2. So the square root of 5 is 2.2. So we got 2.2 comma 0 and negative 2.2 comma 0. So we're going to be at 1.2 comma 2 and negative 2 would be at a negative 3.2 comma 2. So now let's take this. We're going to go left 1 up 2, negative 3.2 comma 2, and this one left 1 up 2, negative 1.2 comma 2, and draw in your ellipse. I hope you did well. So you can either move or do the math. Either way, you should be fine. Okay, let's try yours. Pause and give it a shot. So your original center went 0, 0. The x-axis was at 3. Your y was at 5. And then you did your foci. So you took 25 minus 9 equals 16. Square root of 16 is 4. So your foci is going to be on the y. So it was 0, 4 and 0, negative 4. And draw in your ellipse. This looks like a circle, huh? Okay, now we got to move him. And we're going to move him 3, negative 4. is where we want our new center to be. So we go positive 3, negative 4, and we put in our dot. So now when we put in that dot, we have to move every point 3, negative 4. So we could literally take every point and go 3, 1, 2, 3, down 4, 1, 2, 3, down 4. This one over 3, down 4. This one. Let's do that again. Okay, now take the top ones. We're going to go over 3, down 4. Then this one over 3, down 4. This one over 3, down 4. And this one over 3, down 4. And we could draw in our ellipse. Now mathematically, we're going to look at our first set. So our first set was x was 3, 0, negative 3, 0. Okay, let's add 3, negative 4 to that. So our move is going to be 6, negative 4, and 0, negative 4, which is what we have. 6, negative 4, 0, negative 4. Now let's do our other vertices. So now our other ones were on the y, and they were 0, 5, and 0, negative 5. Let's move those. We're going to be at 3, 1, and 3, negative 9. Let's look. We are at 3, 1, and 3, negative 9. Now we have to do our foci, and our foci were at 0, 4, and 0, negative 4. So our new point is going to be 3, 0, and 3, negative 8. 3, 0, and 3, negative 8. All points match. Life is good. Oh, I did this work up here. So all of that is right there. Okay, let's continue on. All right, we want to create an equation of the ellipse not at the origin and having not to graph it. So we've got the major axis at 2, 2, and 8, 2. The minor axis at 5, 3, and 5, 1. So when we go here, we have to figure out where everything's at. So if you take the major axis, and these are our endpoints, the middle of that should be the center of my ellipse. So to find the center, we add 2 plus 8 and divide by 2, and 2 plus 2 and divide by 2. So my center is at 5, 2. So currently, we're going to have x minus 5 squared plus y minus 2 squared is the part of the ellipse we have at this point. Now we got to find that a and b. Now I got to figure out the distance. Well, we can do the distance formula using the points, or if you recognize that the 2's are the same, the things that are changing are the x's, correct? So since the x is changing, 8 minus 2 is 6, and then so that is the distance of my major, and then I divide it by 2, and that will give me a. So it's 3 long. The same with the minor. The 5 stayed the same, so we're going to take the 3 minus the 1, which is 2, and half of that gives me my minor, which is 1. So we got 3 and 1. So 3 is the major. I know 3 is the x-axis. I square it, and that's 9. 1 is the minor, which was on the y-axis. We squared, and that's 1. And we are done. Okay, pause and try yours. All right, the information is given to you a little differently. You're vertical with a length of 20, so vertical is going up and down, right? So vertical length of 20, that means half of it is 10. All right, so we know my major is the y, and it's 10 long. So right now, we know my major is the y. It's 10 long, so it's 100 underneath it. The minor is 10 this direction, which means half of it is 5. That's drawn terribly. And 5 squared is 25. My center is 2, negative 3, So that's x minus 2 squared, y plus 3 squared, opposite sides. All right, I hope you did a great job on that. I think they're kind of fun. All right, if you have any questions, make sure you're posting them online. And here's your homework, and good luck. I hope you'll do well.